Good evening, students. I'm going to continue with the same lecture, the previous lecture on the quantitative data analysis. When I was doing the previous lecture, the camera was stopped abruptly due to some technical reasons. Okay, so I'm going to do the same lecture once again. Okay, I'm going to revise certain things back. Okay, but I was like trying to make you to understand that the relations between understanding, the relation between understanding, interpretation, analysis, and explanation. I tried to, in this context only, I tried to introduce how to look at the data, or how to derive meanings from the data. Okay, that's the first idea. The second idea is that how to use, for instance, graphs, frequency distribution, and then measures of central tendency. How to use these very simple statistics to explain about the socio-economic data, socio-economic or socio-cultural as well as the economic data, to come up with an engineering ideas. We are not expecting you to use advanced level of statistics. At least, for instance, the basic statistics which we can use, understand the data, and then derive the fact out of it, and then represent those facts to arrive at a novel engineering ideas. Okay, this is a very basic intentions and objective behind using the quantitative data analysis. So the basic idea of the graph. First of all, we need to understand what is the purpose of using the graph. Is that the purpose of using the graph is that to display accurately how the distribution shifts. So you are trying to understand the distribution of the data. So in a graphical representation, that means you are giving emphasis to the shape of the data. Okay, the shape of the distribution. Vice versa, you are trying to understand the data. The second is that what is the real meaning? What is the real meaning of this? Is that how the individual cases are distributed across the values of variables. So that means you are trying to understand how the individual cases or how the individual units are distributed within the values of the variable. That I put it here is that the graph is a kind of a representation which has two sides. One is on the vertical side, we know that, and the one is the horizontal side. Within this, how an individual units, for instance, here the variables would be placed. Here the numbers, the frequencies would be placed here. Okay, so you will be able to see that the distributions, different set of distributions of data. So when you connect this dots, you get a kind of a pictorial representation. This pictorial representation is the pictorial representation makes or conveys a meaning Okay, that makes others to believe in what you have collected as a data. Okay, that's a fact representation becomes very easy. Okay, here when you do this graphical representation, or when you use the graph or the frequency distributions, or even for instance the measures of simultaneity, we have three very basic features. Okay, the first one is that what is your idea, what is your intention behind using the graph or frequency distributions or measures of simultaneity, is that trying to identify the skewness. The first one. Here the skewness is that how the data is irregular in nature, or trying to understand the lack of symmetry. Irregularity in the data. For instance, if you look at that, there is an irregularity. There is an up, there is a down, this is upside, down, once again it goes to up, down. So this is the kind of an irregularity you would like to show. The second idea is that you are trying to understand the variability. Understand the variability. What does that variability infers here is that how the values varies. How the values are vary in the data set. So here you will be able to see that how the values varies. Here is that there is a one value is here, the other values are here, and then the next values would be here, and the third values and the fourth value would be here. So you will be able to see that how the values vary in a data set. Okay. The third idea is that you are also trying to understand the central tendency. The idea of the central tendency is that you are trying to look at or take the typical or you're trying to take a kind of a central point. You are trying to take a kind of a central point of location. Central point of location, or we can simply call it as a kind of an average. How the data is divided equally by taking a kind of the center stage. Okay, this is what the very purpose or the very meaning of trying to understand or trying to use whether it's a graph or frequency distributions, or even for instance the measures of simultaneity. What we do here is that we are actually trying to come up with a kind of an idea of measurements. When you look at the variability measurements in terms of measuring how the variables vary in terms of scales. And if you look at that, the skewness is that, I'm just recollecting it, look at that irregularity in the data set, and at the same time the average. So when you are able to use this, so you get a kind of you derive certain meaning, or you get a kind of representations. That representations which will be helpful for understanding certain characteristics. Okay, certain characteristics of certain variables. Okay. Now the idea is that there are three different types of graphs. The first type is that bar chart. Each type has a specific purpose. Okay. First one is that it's a bar chart. The second one is that histograms. The third is that frequency polygon. The bar chart is specifically used to display the distribution of, it helps to display the distribution of qualitative variables that are discrete in nature. Number first, discrete as well as finite in nature. For example, is that very good example of a kind of a qualitative variable is that you take a religion, or for instance marital status, or caste. You just simply, the bar chart simply like used to be like this. Each bar is placed. So you go to a kind of a village, you are trying to understand that how many people are in the category of Muslim, how many people are in the category of Christian, or how many people are in the category of Hindus. So you will be able to see that it's a kind of frequencies, it's the religion. Normally we use the bar chart for understanding the nominal scales. Okay, nominal scale data. And then the next one is that it's a kind of histograms. The second type is the histograms. The histogram is used to display the distribution of quantitative variables which vary in a continuum. That means there is no gap in the data. There are no gaps in the set. And here the columns are placed in an adjacent. In a graph, the columns are placed in an adjacent mode. For example, this is graphical representations. You will be able to see, for instance, the number of years spent in education. So you are going to the village, you are asking the people, each individuals, that how many years did they spend in an education. Okay, maybe like somebody would say that they might have spent 5 years. So for instance, you start with 0, 5 years, 10, 15, 20, and then the 25 years. So you will be able to see that how many people spend how many years in education. So here it becomes a kind of frequencies, numbers. So it will be like this. Slowly, if there is a rise or not. So it's kind of a continuum. It's a continuum. There is no gap in the data. Basically, the histograms are trying to look at project the history of an individual. Okay, in terms of education. This is purely education is kind of one good example of it. On the other hand, if you look at that the frequency polygon, this particular graph helps us to display the distribution of number of cases. Number one, number of cases as well as the percentage. As well as the percentage. For instance, a good example is that the context of the COVID-19. Okay, the graphical representation is this. For instance, the first COVID patient came in the month of I think at the end of the January. Okay, and slowly it started picking up, and slowly there is a rise in the data. Now there is increase in the number of cases. At the same time, you will also able to project within the frequency polygon how many people have recovered and how many people are dead. So in a single graphical representations, you will be able to show multiple projections. Okay, so that's where that the frequency polygon would be helpful. compared to, for instance, the bar chart or for histograms. Okay, normally this is used to project a different set of variables to project one particular phenomenon or one particular phenomenon. Okay, regarding the disease, here is one particular phenomenon is a disease. Okay, so you are saying you are trying to tell that how many people are affected and how it is increasing, how many people have recovered from the disease, and then the next line you are trying to project is that how many deaths happened because of that particular disease. So in one graphical representation, one graphical picture, you will be able to show multiple data. Okay, this is where we use the frequency polygon. Okay, at the same time, when you are moving towards, for instance, the frequency distribution, that's a frequency distribution. The very idea of the frequency distribution is to show two things, like so much more similar to the frequency polygon: the numbers as well as the percentage. So this is clearly used for the univariate variable, but at the same time the frequency distribution we would like to project it in table format, not through the pictorial representation. It has 3 different columns. The first column is the values of variable. The second is frequency. The third is the percentage. So you go to a kind of, for example, you go to a field, you are trying to ask, normally the students used to ask that how many people are interested in skill development programs. Skill development programs, or you might be having a certain specific project for the village development. So you're going to ask how many people are really interested in your project. Okay, so that is whether they are interested or not interested. So you have a different set of categories. The first category is that people who are interested in that. The next category would be a kind of not interested. The first category is interested, and the next category would be a non-interested. Then the third category would be a kind of an invalid, and the fourth category is that they don't respond. So you're going to ask 100 people how many people are interested. So the first one is that you're going asking 100 people, out of 100 people they say that 60 people are interested, and the next 20 are not interested. At the same time, invalid is that you are asking the appropriate question to an inappropriate respondent, and it becomes a kind of an invalid. And the other 10 people they're not even responding, they didn't say anything. So you put a kind of a 10 here. So how many people you have interviewed is that? The total interviewed is the total actual interview which has happened with 100 people, but out of this 100 people, only 90 have answered it, including they didn't respond. They say no, neutral categories. Okay, but the rest of the 10 people are invalid. That means you have asked an appropriate question to an inappropriate respondent. So now you convert into a kind of a percentage. The percentage is that it's a 60. By default, it comes 60, 20, 10, 10. Okay, 10%. So you can either you can put it the frequency distributions, even you can convert into an graphical representations. Graphical representations. But you have to make sure that which graphical representation is best to project this particular data. Okay, that means you have to look at the purpose of the projection of the data. Okay. The next is that the measures of saddle tendency. I just would like to keep it more simplified understanding of very simplified understanding of the measures of saddle tendency. I'm not going to delve into very deeper because you are already trying to expose towards an advanced statistics at the BTech second year itself. Okay, so trying to dwell deeper into this, I would say that we will be like engaging with maybe a kind of an it's not an advanced course basically. Okay, for advanced course in statistics, at the same time there is not an advanced course in for instance research methodology. Okay, so I would like to limit this idea of quantitative data analysis to our project, to our specific purpose of trying to understand what are the data you try to collect it from the field. So how far one can use better the data. Okay. So the measures of the saddle tendency is that you have mean, median, and the mode. Okay. So the mean is about a kind of the arithmetic values. So you take a kind of an average of it, and the median would be a kind of a middle value,